Hey team algebra, here we are in unit 8. So we're gonna do a lot of factoring in unit 8. It's kind of going backwards from what we ended up with when we were multiplying the polynomials together. We got an answer. We're going to kind of go backwards. We're going to have the answer and go back and see what multiplied to get the answer. So I'm just going to get started with a couple of these first examples. See if I can get my good blue pen going there. So in this first example, if your product of two things multiplied together is 18c to the ninth, and they give you one factor right here, and they say, okay, what does negative 6c to the fourth have to be multiplied by to end up with a product of 18c to the ninth? So obviously, to get from negative 16 to positive 18, you need to multiply by negative 3. And to get from c to the fourth power to c to the ninth power, remember when we have like bases and we're multiplying, we add. So what do we have to add 4 to get to 9? C to the fifth. So that's the answer. And you certainly can check back. I would definitely, especially on a test or quiz, I'd be multiplying these guys back and make sure that my product really is this product that I started with. Negative 6 times negative 3, positive 18. C to the fourth, C to the fifth. We're good. All right, let's look at the second example. You might be able to just do this one on your own. How can I get from 8 to 16? Multiply by 2. How can I get from x squared to x to the fourth? X squared. And I have y to the first, and I need y to the third, so I'm going to multiply by a y squared. And I can prove it. 8 times 2 is 16. X squared times x squared is x to the fourth. And y to the first times y squared is y to the third. So that's just a couple little random examples of giving you a product, and you tell me what the factors are if I give you one. We're going to talk a lot about factoring, and we're going to talk a lot about the greatest common factor. And just to remind you, those of you that had me last year, you might remember how we did the GCF in my class. I'm going to reintroduce it this year again, because there's a couple different ways to do the GCF. And one way you can start when it's just numbers is you write all the factors of the number. So 48, 1, and 48. Does 2 go into it? Yep, 2 and 24. 3 also goes into 48, 3 and 16. 4 goes into 48. Pick one with a lot of factors. 4 times 12. 6 goes into 48. 6 times 8. 7 doesn't. Of course, 5 doesn't. And by the time I get past 7, I'm back to one of the factors I already have listed. Let's do the same thing quickly for 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. But you don't have to write the 6 twice. You can. Anyway, so the idea behind the GCF is looking at all the factors of these two numbers. What's the largest one, the greatest one that they have in common? Well, they've got a bunch of factors in common, all these first 4 factors, but there's one that's biggest, and that's 12. So this is probably in elementary school. This is how you did the GCF. Which is all well and good when you're dealing with small numbers and you don't have any variables. The way that I taught it in 7th grade was start with the prime factorization of each number. So let me remind you what a prime factorization looks like. For 48, you can start with 12 times 4 or 2 times 24 or 6 times 8. It doesn't matter, but you're going to continue to break your factors down until you are left with nothing but prime numbers. So before I'm going to write this in exponential form, I'm going to make sure that I can get back to my product of 48. 2 times 2 is 4. Doubled is 8. 8 times 3 is 24. Doubled is 48. So I'm pretty satisfied that the prime factorization of 48, I'll write it over here, is 2 to the fourth times 3. And you write them in base order. So 2 is smaller than 3. He comes first inside the box. Box it up. 36, I'll just do 6 times 6, which is 2 times 3 times 2 times 3. Whoa, 3. So 3 times 2 is 6, times 3 is 18, double is 36. So I'm pretty confident that's 2 squared times 3 squared in a box. So now when I'm doing the GCF, all I care about is what is inside these boxes. All this other work is off to the side. That's all well and good. But now to find the GCF, two things. They must have a common base. So the base must be in all of the prime factorization boxes. And then number 2, you use the smallest exponent that you have. So in this case, I have a 2 in both boxes, and I have a 3 in both boxes. So that's good. I can use both of those bases, but my smallest exponent is what I need to put on this 2. So I've got a 4 and a 2. Obviously, 2 is smaller than 4. And 3, here's 3 to the first power. Anytime I see something to the first power inside the box, I don't care even what's in the other box. I know there can't be anything smaller than the exponent of 1. So 2 times 2 is 4, times 3 is 12. So same answer, different method. We're going to use this method. We're not going to be making lists. Let me run through a couple that have monomials, that have variables. Again, start with the prime factorization. Well, in this case, there are no numbers, so you don't have to break down any numbers to get to prime numbers only. And when you have no numbers, your variables come down in your prime factorization just like they're written. So if I were to write this with a box around it, it would look like this. I'm just recopying the factors. So the GCF, so variables are easy, in other words. It's the numbers that take a little bit more work. So the GCF, we have to have it in both boxes. So I see an X in both boxes. I see a Y, and I see a Z. These aren't very good examples because there's nothing that's not in both boxes. But if there was another variable over in this box, let's say a Q, then he would not come down as part of your GCF. They have to have them in common. And now we're going to take the smallest exponent I see on each of these variables. So x to the 4th, x squared, I'm using the 2. Y to the 2nd, y to the 3rd, I'm using the 2. Z to the 1st and z to the 4th, z to the 1st. That's the GCF between these two factors. If you look at the second example, we'll finish this one up really quick. I do have to do the prime factorization of 8. That's 2 cubed. X to the 5th, y to the 6th. Box it up. 12 is 6 times 2, which is 3 times 2 times 2. So that's 2 squared times 3. X to the 7th, y squared. So now I'm ready to look inside my boxes to get the GCF. They have to have it in common. I see a 2, a x, and a y, a 2, an x, and a y in both boxes. This 3 is over here, but he's not over here, so he cannot come to the GCF party. All right, now I got to go back and put the exponents on it. Smallest exponent is 2 squared. Smallest exponent for x is to the 5th. 5 is smaller than 7, and y squared is the smallest exponent. So we need to multiply this out. That's 4. 2 squared is 4. So you're going to simplify this, and that's your GCF. All right, see you on the next video.